Okay, so shall we begin? Well, good morning, everyone. My name is Rodrigo. This is Mateus. This is Gabriel. And part of our team is on the audience today. It's Guilherme and Luis Gustavo. So we are here to present and talk a little bit about our summer research project. So the introduction. It is known that the IIT campus provide many facilities and places for events and seminars. One of them, the Wishnik Hall, which was built in 1945, counts with 5 classrooms and 1 auditorium. Once you are inside that building, you can access the auditorium through 2 doors. Both doors, they are made of wood, and they are about 7 feet tall. So we should have an idea of how heavy those doors are. However, as they have 3 mechanical joints in each side, they can be operated very easily. So a 5-year-old child could easily open and close that door. On the other hand, it can lead us to a problem, and we made a video in order to illustrate that. So here, let's suppose there's something going inside the auditorium, some kind of a class, a seminar, a presentation. And there are people walking outside of it, which is not an unusual situation. And as the presentation, the seminar comes to an end, naturally people will pack up and walk towards the exit of the auditorium. As the door can be operated very easily, that kind of issue could happen. So based on that idea, what our project reads, what our project has as an objective, to develop a door opening warning sensor that would detect people that are walking towards the exit of the auditorium and warn people that are walking outside of it.
Well, so it was me in that video, but don't try to do that at home. It hurts. Okay, so in the development of this sensor, we wanted to serve the entire community. So as we know that there are people who cannot see visual warnings or listen to audible warnings, we use both. So even people with disabilities will be served with that. And we wanted to make a friendly project, for the environment. So that's why we decided to use solar panels to power our project. However, when we use solar panels, we have some issues that we have to consider. As you can see in those charts, the orange line represents the energy we can get from outside the building, and the blue line represents from inside. And as you can see, the inside energy is like 70% lower than the outside energy. It's a huge attenuation, and we had to consider that. So we dimension our project for that kind of situation, and it works even with a small amount of energy.
As we are using Arduino in our prototype, we programmed in C++. As you can see on the piece of code in the slide, we truthfully commented our code. This is because we noticed that we are interfacing with a lot of LEDs, buzzers, and sonic rangefinders, and etc. And this made our code not short. We implemented our algorithm in a smart way, that it does not depend only on the distance from the door, but also the direction of the movement. So for example, if someone is leaving the auditorium, the alarm will sound. If someone is entering the auditorium, the alarm will not sound. If someone is leaving but stops in the middle, the alarm will sound while this person is walking. As soon as he or she stops, the alarm will keep sounding for 1 second or so and then cease to sound. We tested our prototype in several setups. We used power outlets, we used solar panels, we used backup batteries, and in all of these cases we never experienced any kind of underage. So our prototype meets the requirement of current and voltage draw.
Since the beginning of our project, we wanted to install it, at least for testing. So we thought, okay, we need to develop a more user-friendly model, a model that looks good, that looks at least presentable. So what we did is that we worked at the idea shop, we recycled, actually we adapted 2 empty boxes, basically 2 cases, to our project. And after that, we installed our device and we recorded another video now showing how it would work. So here we have the same case scenario. We have a presentation, something happening inside the auditorium while people are walking outside. So as it comes to an end, people will back up and start walking towards the exit of the auditorium. But now, contrasting the previous one, there's our device installed. the sensor will detect the person that is approaching in order to exit the auditorium and warn people outside of it, now preventing the issue that we had before.
And as we concluded our project, we achieved all the objectives that were proposed in the beginning. However, as any other project, we have some optimizations to do in it. And I think this part is very important for the next team who's going to work on this project. So the first optimization could be the replacement of the sensor for a camera that could perform image processing. With that, we could apply much more features to it. For example, we could count how many people are inside an event, and control an event. In addition, it is possible to design a permanent case for installation with the luminous exit in it. So those signs for exit, if we could place our project inside of that, it would be invisible and it would not disturb any layout or design inside the auditorium. And in addition, we could design a more compact PCB, so it would be smaller and cheaper, especially for large-scale production. And we could make it already is actually interchangeable between different power sources, but we could make it as a product. We could make it with different options so that the customer could choose the best power source for him. For example, sometimes some people are not going to have an available window or the sunlight's not good in that place, so they would prefer to use batteries or power outlets. So that's it. Thank you so much for your attention. We're going to be probably here in the corner with our project. We have the prototype here, so if you have any questions or if you want to see it working, just come and talk to us, okay? Thank you so much.
Thank you.